Hello friends, today we are going to discuss about crystal planes and directions, how we can index them and in hexagonal system, cubic system and so on, and what is the procedure of indexing, and what is the importance of why we want to understand that how to index these planes and directions. We will start with that first. So, the importance of why we want to understand that why which planes are numbered or how you can name the planes or the directions. One of the example is here on the slide, that there is a problem called earring, okay, in during deep drawing operation. So, basically if you want to make a can, okay, for example beverage cans, the Coca-Cola or Pepsi cans which you cold drink cans which you use, okay, these are all deep drawing made by deep drawing operation. And if your which type of planes are parallel to the surface and what kind of directions are there, depending upon that you will get a certain problem which is called earring problem, okay. And to control this kind of which type of planes and directions are there parallel to the surface and parallel to a certain direction, if you do a good control, okay, then you can get rid of this earring problem. You can understand that when you have earring problem, okay, you have to remove this much material to get a final shape like this. Also there will be, because there are different type of deformation at different part of the cup, you will have thinning of material at certain point and at other point there will be a thick sheet. So, there will be a difference in the thickness of the sheet or sheet in the cup, okay. So, which is not a good thing, and we will not be able to design any of our part properly if there is the thickness difference, okay. Another example is for electrical transformer. If you know electrical transformer, this is a core, okay, laminated core, these are primary coils, these are secondary coils, and when during AC current if it is it has a 50 hertz cycle, that means 50 times it is the polarity is changing from positive to negative, okay, and because of that there is an induced flux through the core which flows as shown by these lines, and that induces the current in the secondary coil. By experiments people understood that if a 100 direction of a particular crystal, okay, in this case because this is electrical transformer, electrical steel is there, okay. So, in BCC materials or BCC crystals, 100 direction is the easy magnetization direction. That means you can easily have magnetization, and you can understand 50 times it has to magnetize, demagnetize, okay. So, with each cycle there will be a hysteresis loop, and for in each hysteresis loop there will be loss of energy, okay. So, it will get heated up, you will also have losses in the distribution. So, all these things we of course we do not want, okay. So, we know that 100 direction is the easy magnetization direction. So, I want to have the grains in this particular material such that the 100 direction is lying in the direction of the flow of this flux, okay, or magnetic flux line, okay. So, that my losses can be minimized, and of course heating of the transformer can also be minimized, okay. So, you can understand that I have to understand these planes and direction, okay. In plastic deformation also later on we will see that some planes and directions are preferred, or where the deformation actually takes place in those particular planes in a particular direction, okay. So, understanding of planes and direction, that which type of plane I have to give some name to each plane and direction, okay. And naming is what is, you can see here some name is given, like this is 100, this is 011, this is 100, and we want to understand that how I can find out all this indexing or name for a plane or direction, okay. So, that is what this particular lecture is about, that how to index planes and direction. You please understand that this planes and direction is all imaginary things. Actually, only there are atoms arranged in the lattice. Okay, we imagine that okay, they are arranged in a particular plane or they are along a particular direction. Okay, so the idea for this indexing or the methodology was given by Miller, okay, William Miller in 1839. So, he proposed a system that how you can index these planes and directions. Okay. For example, for directions he proposed that he said UVW can be the name, and if you enclose them in a square bracket like which is shown here, then it will be direction. That is how you can denote the direction. Family can be denoted by something like this. Okay, we will find out what do we mean by family. Planes can be shown in this parenthesis, okay, and family can be shown is in curly braces. Okay, so we will see what do we mean by this. These are just notations which are used, okay, which you will use for denoting planes, family of planes, directions, family of directions. To start with, for example, how to find out the direction. Okay, let us say that we will take a cubic crystal, okay, a unit cell of a cubic crystal. Okay, and we have, let us say this is x direction, this is y direction, this is z direction. Okay, along x, y, z direction I have lattice parameter a, b and c. Okay, so if I have to define a vector, okay, let us say a vector r, okay, which is passing through a coordinate point, let us say UVW, suppose somewhere it is like this is my UVW, the coordinate points. Okay, so any vector which is passing from the origin through this point, okay, through our vector algebra, I can say that this r vector is actually, I have to go in all the three principal directions here along a, b and c. Okay, and if this is UVW, then I will say that r is equal to u a plus b b plus w c. Okay, so this is my vector. So you can understand that to go from origin to this particular point, okay, I have travelled u times in a direction, v times in b direction, w times in c direction, and this is how you can give the indexing, that if this is the UVW, then my indexing of this particular direction r is given by UVW. Okay, so in the next slide I will give you this algorithm for indexing this. Okay, so the first point is that once a vector or direction is given to you, if it is not starting or passing through the origin, okay, you reposition. Suppose instead of this vector, suppose I would have given a vector like this. Okay, and now it is not passing through the origin of this particular unit cell. So what I can do, I can take a parallel vector which is passing through the origin. Okay, then I can do the all the calculation or how I can get this vector very easily. Okay, so first I will make it to pass through origin if it is not passing through origin. Then we will find its projection length, okay, in terms of unit vector ABC as we have just did. Okay, UA, BB and WC. There is another way of also finding out the coordinates of this particular vector is if you have the coordinates of the starting point and the end point, okay, you do the subtraction and that will be the coordinate of this particular direction or vector. Okay, but we will not do this, we will follow the one which is given by this particular condition. Now once you are doing this, you will not be going along these ABC direction in integer values. Okay, sometime you may end up with fractions here. Okay. So, we usually we don't like fractions. Okay. So, this is just a kind of a liking for particular numbers. Okay. So, instead of fractions, Miller suggested that you can have integers. So, the fractions will be converted to lowest integer values by multiplying by a common factor. Okay, and then whatever you get will be enclosed in a square bracket UVW without commas. Okay, so that is the whole algorithm for finding out the direction. Okay, let us say take some examples here which will help us in understanding this. Okay. Okay, so again I will make the unit cell here for a cubic crystal. Okay. We will take mostly the example of cubic crystals. Okay. We do not want to go into too many complications here right now. Okay. We just want to understand whether how I can do the indexing. So, suppose I am interested in knowing that what is the indexing of this particular let us say vector or direction. Okay, and this is A, this is B, and this is C. Okay. So, again as we saw that you have to see that how I am going in these 3 different directions. Okay. So, to find out the direction of or indexing of this direction, I am starting from here. Okay. This is my starting point. Now, I am going 1 unit in the A direction. Okay. So, this is my direction. Okay. I will not extend it right now beyond this. So, I am going 1 unit in A direction. Okay. I am not going in B direction or C direction. Okay. So, this is 1 times A and nothing in B and C direction. So, I will write the indexing of this will be 1 0 0. Okay. I have not put any commas here. Okay. Now, we will not keep on doing again and again that. Let us again take another little bit more complicated direction. Let us say I want to find out the indexing of this direction, which is joining this particular origin, okay, with this particular point. Okay. This is the back face of the cube. Okay. So, for this I cannot go in A direction. Okay. I will be going in B direction, okay, 1 unit, then I will be going in C direction 1 unit, okay, and I will reach there. So, the indexing of this particular direction is 0 1 1. Okay. Now, let us say we take another complicated, and by the way, this particular one is called face diagonal. Okay. Let us say another one, okay, which is joining this origin, okay, with this particular lattice point. Okay. So, I am starting from here. Let us say I draw it with a certain different this thing. Okay. I want to know the indexing of this one, okay, from this particular point to the diagonally opposite point here. Okay. Now, for this one I will be going, because I have to reach there. So, I will be going 1 unit in A direction, 1 unit in B direction, 1 unit in C direction to reach this point. Okay. So, I am going 1 unit in all directions. So, it will be the indexing will be 1 1 1, and this is what we call as body diagonal. Okay. Let us see if we have fractions here instead of, these are all in units, unit lengths. Okay. Let us see if we have fraction instead of unit length. Okay. Now, let us say we are not going up to that, let us say we are starting from here and maybe going up to a half distance here. Okay. So, this is my direction, okay, starting from 0. So, this is again my A, this is B, this is C, this is origin. Okay. Now, I am going half in the C direction. So, I do not have to go in B direction here now, I will be going in A, okay, and then I will be going half in the C direction. Okay. So, now I will be not writing directly there, I will be writing that I am going 1 in A direction, I am not going in doing anything in the B direction, and I am going half in C. Okay. So, now this is a fraction, okay, and as I told you we do not like fractions, I want to have integers here. Okay. So, the common factor here is 2, if I multiply it by 2, okay, then I can get rid of this fraction here. So, I will multiply the whole thing by 2, so it will be 2, 0 will remain 0, this will become 1. Okay. So, this particular direction now is 2, 0, 1. Okay. So, fraction also you can easily handle, whatever this thing is fraction is coming, you take common factor, multiply by that and get rid of the fraction. The thing you have to remember is that it has to be for the whole calculation, it should be the, you should get the lowest integers. Okay. Now, sometime it may happen that you have to go in a negative direction. Okay. So, let us see what we will have if we are going in a negative direction. Suppose my vector is not starting from the origin here, okay, and let us say I want to know the just opposite vector of the one which we found out here. It starts from here and it is ending here. Okay. In this case, what we have to do? Okay, this is my starting point. Okay. Now, I have again I will do the same thing, I will go in A, B, C along A, B, C directions. Okay. So, first this is the A, so I am going in the A direction. Now, according to this particular unit cell, okay, where this is the origin, I am going in the negative direction, all these are the positive directions. Okay. So, if I am going like this, then I am going in the negative direction to the A. So, I am going negative 1. Okay. Now, this is the positive B, I am going in negative B, okay, and this is the positive C and I am going in the negative direction to that to reach the end point. Okay. So, the from origin start of the direction to the end of the direction, what path we have to trace, that is what we are seeing here. So, in all these cases we have gone negative, negative, negative. Okay. Now, how to write this in our this form of direction? Okay. I will be writing it like this, I will put a bar over the number. If it is negative 1, I will put bar 1, again bar 1, bar 1, again without any commas. Okay. So, if you have if you are going along a negative direction, then you have to put bar 1, bar 1, bar 1 to get the direction. Okay. So, I think we have covered different scenarios here, how to get indexing for different directions. There can be even multiple ways of finding out the direction, multiple directions to find the indexing for, that we will do when we will do the assignments. Now, we will come to the how to have the indexing of the planes. Now, again you see that what steps we have to follow here. Okay. In case of planes, we will take the intercepts. Okay. So, that particular plane, what kind of intercepts it is cutting at these 3 different directions A, B, C, okay, of the crystal axis. Then we will take the reciprocal of those numbers. Okay. So, this is an additional step here which was not there in the direction case of direction. So, we will take reciprocal of the intercepts. After taking the reciprocal, if there are any fractions, okay, values are coming in fractions, again we will take care of that by multiplying by a common factor, okay, to get integers. So, again our love for integers is there, okay. So, we do not want we will take first the intercept, then we will take the reciprocal of those intercepts, then we will find out the integers, okay. Of course, we want to have smallest integer values here, okay, and then we will enclose them in parenthesis without commas again. If you have a negative intercept, as we saw in the case of direction also, it will be denoted by a bar over the integer. If plane is passing through the origin, okay, then we will have a problem because we cannot have an intercept. Then you can take a parallel plane of that particular plane, or you can shift the origin itself keeping the same sense of crystal axis. This is important, okay. When you are shifting the origin, how the axis, the positive direction of and negative direction of axis will remain same, okay. We will see all these cases as an example here. So, let us say again we take a cubic unit cell for a cubic crystal. Okay. And this is your again A, this is positive A, B, C. Okay. These are my positive directions for ABC. Okay. Let us start with a simple plane first. Okay. Let us say I want to know indexing of this particular plane. Okay. So, I am just marking it that I am interested in this particular plane. Okay. So, our first step is to find out the intercepts on the on this particular directions ABC. Okay. So, this particular plane it is not going to cut A because it is parallel to A. This particular plane is not going to have any intercept on C because it is also parallel to C, but it is going to cut the B axis at unit distance here. Okay. So, if I want to write the intercepts, in case of A there is no intercept. Okay. So, basically intercept is at infinity, okay, because both the plane and the direction are parallel. Then we say that they are going to make an intersection at infinity. Okay. So, this is going to be at infinity. In case of B, the intercept will be at 1 unit distance, and in case of C, right now I am putting commas because I am not giving the final indexing of the planes. Okay. And for C it will be again infinity. So, these are my intercepts. Okay. Now, this is why we are taking reciprocal here in case of planes, okay, because we again do not like this concept of infinity, okay, that how to define this infinity. Okay. So, the business of taking this reciprocal in case of plane is just to get rid of this infinity. So, when I take reciprocal here, okay, this infinity becomes 0, obviously 1 will remain 1, and again this infinity becomes 0. Okay. Now, in this case, because all are in integers, okay, so I do not have to do anything. Okay, this will remain like this, and I can write finally that what will be the indexing for this particular plane. Okay. Now, you can do very quickly that if I want to find out this particular plane, okay, let us say I do the hatching like this, okay, which is cutting the A axis at unit distance, then of course it will be 100, similar exercise. If you want to find out for this, okay, it will be 001. Okay. So, very quickly you can see this, okay, that you can find out the these 3 planes very quickly. Okay. Now, let us see what happens if I want to find out for this plane. Okay. Let me again draw another this thing unit cell. Let us see, I will draw it here. Okay, you should do a lot of practice with drawing all these things, okay, so that it does not take much time. Again A, B, C, okay. These are all my positive directions, okay, and this is my the origin, okay. Now I want to know, for this plane we have already seen, I want to know that what is the indexing of this plane, okay. Again the same plane, the plane like this, it is a parallel plane to this, but the problem is it is passing through origin. Now how to find out the intercept, because it is passing through the origin, okay. So very convenient way to find out this is that you can shift the origin. See, origin is arbitrary, you can put origin anywhere, okay. We have put for our convenience at this point, okay. So let us say I am not happy with this origin, I put the origin at this lattice point, okay. But as I told you in the last statement here, that I will still keep my directions, okay. That sense I am not going to change, okay. So again my A is in this direction, okay. Positive A is like this, positive B is like this, and positive C is like this, okay. That is not changing, origin has changed, okay. So now I keep the same thing, this is my origin now, and now I see that where this particular plane is making an intercept, okay. So it makes an intercept in the negative direction of B now, okay. In this case it was making the intercept in the positive direction of the B, okay. So when it makes in the negative direction, now if I want to write again the intercepts, okay. So I will again write intercepts here first. So it will be infinity, -1, infinity, and then I will take the reciprocal, okay. So it becomes 0, -1, 0. So my indexing will be 0, bar 1, 0, okay. So now we have seen for a negative one also, if it is passing through the origin, okay, it is convenient to just shift the origin. Sometimes you can also take a parallel plane, but for some plane finding out a parallel plane becomes a big headache, okay. You cannot do it easily, okay. So shifting the origin but keeping the sense of the axis is much better way of finding out the intercepts, okay. Let us take a little bit more complicated plane than this one to get more sense of finding out the indexing. The idea is to find the indexing of some of the important planes of cubic crystal, because that is what is going to come later on, okay. So again this is my origin, this is A, this is B, this is C, okay. Let us say I am interested in a plane like this, okay. It is going like this, and the back phase also it is going like this. So this is the plane I am interested in, okay. A diagonal plane like this, okay. Now again find out the intercept. So intercepts are, it is again parallel to the A axis, okay. So intercept at the A will be at infinity, it has an intercept of 1 in the B, so 1, intercept of 1 in C, so again 1, again we will take the reciprocal of these values, so it will come 0, 1, 1, okay. And then I will just write it in, sorry, I am writing it in the wrong way, okay. It should be parenthesis, it should be parenthesis 0, 1, 1, okay. So earlier also I think I made a mistake of putting the this indexing, this should all be in parenthesis. Okay, please remember that. Now let us say we will go to a little bit more maybe where you are getting the fractions here. Okay. So, again I will draw the okay, and let us say the plane is something like this. So, this is my origin A, B, C, okay, and somewhere here this is the plane we are talking about. Okay. So, it is cutting at some location half of the C, okay, and one unit in A and B direction. So, again we will take the intercepts. Okay. So, intercepts will be 1, half and 1, okay, and now I will take the reciprocal first. Please remember, we are not making integers at this moment. First we will take the reciprocal. So, it will be 1 to 1, okay. Now, it has already become integer, so we do not have to do anything, okay. I will just write it in parenthesis like this, okay. You may sometime get a fraction such that you have some number here also. So, when you take the reciprocal, you get some number in the denominator. So, you just have to multiply by that common factor to get the integer values here, okay. Now, there is another concept which is given in the slide, which is called family of planes, okay. So, just see this concept, family of directions and family of planes. So, for example, okay. So, we said this crystal axis A, B and C have in case of directions have the indexing like this 1 0 0 0 1 0 and 0 0 1, okay. Now, you can also have negative of this, okay. Suppose instead of going like this, okay, I am going in the opposite direction, I am starting from here and ending here, okay. So, I am going in a negative direction, then this will be bar 1 0 0 0 bar 1 0, okay. Now, in terms of length of each of these vector, these are all same vector, they are a part of the same family, okay. So, to represent this, as was told in the first slide, this particular slide, that when you have this kind of family of direction, okay, I can represent this whole thing. I do not have to write every time all of them if I want to tell the family, okay. I can just write it like this, okay, or maybe if you like this, I can just write to it represent all the 6 directions, okay, which you have shown by a family, okay. So, I just have to put these braces here, okay, and that will give me the family of direction, okay. Why we are interested in family of direction? Because if you see, if I just change the orientation of this particular unit cell here, 1 0 0 may become a 0 1 0, okay, or 0 1 0 may become a 0 0 1 if I change the orientation of this, okay. So, there is, and if you see the properties, any properties along this direction, okay, for that particular property, all directions are same, because their interatomic distance will be same in all these 3 directions, okay. So, for a property, it does not matter whether it is 1 0 0 or 0 1 0, all are same. So, I can just represent them by a family of directions. Okay. Similarly, in case of planes also we can represent a family of planes. Okay. This is A, B and C, these are all positive directions with the origin here. Okay. Again, let us say we talk about these particular planes, okay, or this particular plane, they are all same, okay, of similar type. So, I can put all these planes as 1 0 0, 0 1 0, 0 0 1, negative of that, and they are all family of planes, okay, and I can represent them by these curly braces by writing it like this. Okay. So, they are all same, okay. Their interatomic distance is same for all these planes. So, they are of similar type. If I take any other type of planes, okay, then I have to find out that what will be the different planes of a family, okay, and I can represent them in a curly braces. Okay. Again, we will do some assignments on this which will clarify this whole concept more clearly. So, now when we have a hexagonal system, okay, the story will be slightly different because we have now 4 axes for the crystal. Okay, as you can see in this particular hexagonal crystal, it is A1, A2, A3 in the basal plane. This is what we call as basal plane, and the C is perpendicular to that. Okay, and the indexing will be like this. So, instead of our Miller indexing system, we follow Miller-Prevost system of indexing, which is a 4 index system. So, plane will be given as H K I L, where I is also is related to H and K like this, I is equal to minus of H plus K, and direction will be given by U V, and there is an additional T here and W. Okay. So, instead of following 3 indexing system, we will follow the 4 index system in case of hexagonal crystal. Okay. Now, the question is why we want to do this kind of thing. Okay. So, let me explain this with a example here. Let us see, we have all these planes here, as you can see, this green, blue, this white one, and there are 3 in the back. These are all prismatic planes. So, it is a hexagonal prism, and these are all prismatic planes. Okay. So, let us see if you have we do not follow this Miller-Prevost system, we will still follow the older, the one which we have already discussed, the Miller indexing system to index these particular planes here. Okay. So, let us say the green one, if we want to see, okay, the green one will be BA1 1 0, okay, because it is cutting the A1 axis in the negative direction, as you can see here, this is the origin in the negative direction, it is cutting the A2 in the positive unit direction. Okay. So, it will be BA1 1 and it is parallel to C. Okay. So, there is it is going to cut at infinity, taking reciprocal will give me the indexing as 0. Okay. Now, let us say I want to now index this white one here. Okay. So, not the blue one, let us say we want to discuss index the white one here, okay, the front plane. Okay. Now, what will be the indexing of this particular white plane? Okay, if you see this plane, okay, it is parallel to the A1 direction and it is cutting the A2 at this particular point, okay, at 1 unit distance from the origin. Okay. So, now the indexing for this particular plane will be, it is parallel to A1 direction, cutting A2 at 1 and it is parallel to the C direction also. Okay. So, now if you see, for one type of prismatic plane I am getting the indexing like this, for another one I am getting the indexing as 0 1 0. Now, you compare this with the our cube 1. Okay. So, this was also a prism, okay, a square prism, and these are the prismatic plane in this case also, and for all these planes, this one, this one, this one, the indexing was looking very similar. And for this one it was 1 0 0, this is 1 0 0, this is 0 1 0, and this is 0 0 1. Okay. So, there is no difference, it all looks similar, that is why we said it is a family of planes. But here also these all prismatic planes have the same, should have same indexing, but when I use the 3 indexing system, they were showing different indexing. Okay. That means there is some problem here, okay, and that problem can be rectified if I find out the intercept in all the 3 direction, all the 4 direction to get a indexing. Okay. So, again we will follow the same principle of intercepts, taking reciprocal, finding out the integers, okay, and giving the indexing of that. So, let us say we now take the 4 indexing system. For this, again same thing, let us say for green one, okay, let us say for the green one. Okay. Now suppose A3 is also there, which was we ignored last time, and this is the green plane, it is cutting A2 here, A1 at the negative. Okay. But now we will consider the third one also A3, it is parallel to A3, you can see this particular plane is parallel to A3 and also parallel to C. So, for this one I will write it as bar 1 1 0 0. Okay. And you also remember that when I said that we follow this HKIL, in case of hexagonal we said that I also has some relationship with the HK like this. So, H is negative, K is positive, minus 1 plus 1 will be 0. So, I will be 0, and which is the case here. Okay. Now, let us say about white one, which we had problem last time. Okay. So, let us say white one here, what will be the indexing? Now, it is cutting A2 here and it is cutting A3 in the negative unit length here. Okay. So, now in this case it will be, and it is parallel to A1, which we saw last time also. So, in A it will be 0, A2 it will be 1, A3 it will be negative 1, C again it is parallel to C. Okay. Again you can check whether this is followed here, H is 0, K is 1, 0 plus 1 1, minus of that it is coming negative here. So, we are still we are doing it correctly. Okay. So, like that we can do for all prism, and you will see all will have very similar indexing. For example, for the blue one also quickly I can do, let us say for the blue one, okay, A1 positive, it is parallel to A2, it is cutting A3 in negative direction, and all look similar, okay, as you can see. So, now there is no problem of having different indexing for the same type of plane, they all now look similar to each other, okay, and that is why we follow the 4 indexing system. Okay. So, now the indexing remains same as we have already seen in the earlier case. Okay. If you want to draw different planes in the hexagonal system, okay, you can do that. For example, this you have to start drawing quickly. Okay. So, this is how it is. something like this, sun. Okay, and this is my C axis, these are my A1, A2, A3, this is A1, A2, A3. Okay. So, suppose I am interested in a plane which is cutting A2 here, A1 here, and let us say it is making an intercept here. So, maybe something like this. Okay. So, we are interested in a plane like this. Okay. Now, let us see, in A1 it is cutting at the positive 1, in A2 also it is cutting at positive 1. Sorry, I will first write the intercepts and then we will see what is happening. Okay. So, intercepts I am writing first 1, 1. Now, it is also making an intercept for the A3 axis, okay, and it is in the negative direction. Okay. So, if you do a little bit trigonometry here, you will find out that it is cutting at half of A3. Okay. So, it will be half here, and in C again it is making at 1. Okay. Now, we tell the reciprocal, so it becomes 1, 1, 2, 1. Okay. Sorry, it is in negative, this is negative. Okay. So, in terms of the how to write this in terms of our indexing system, it will be 1, 1 bar 2 and 1. Okay. So, this is how I am going to write it. Any other plane we can take, or we can take some plane in the assignments also to get hang of the indexing system for planes. Okay. Now, we will come to the directions of hexagonal system. Okay. And direction, actually you will start getting some dizzy spells. Okay. So, you have to be careful when you are doing indexing of direction in hexagonal system. Okay. And the reason is that again you have to do something, you have to see some funny things which are happening here. Okay. For example, if you just follow the what we did in case of when we were using Miller indexing system. Okay. Okay. So, I am taking this cube again. Okay. So, this my primary crystal axis which were given like this were 1 0 0 for A, for B it was 0 0 1 0, C it was 0 0 1. Okay. Now, if you try to follow that same here, okay, it should be for A1 it is 1 0 0, for A2 it should be 1 0 1 0 and for A3 it should be 0 0 1 0. Okay. But it is not like that. Actually, if you see in the 4 indexing system, the A1 is 2 bar 1 0, that is the indexing. Okay. That means, I have to go 2 units along A1, negative 1 unit along A2, negative 1 unit along A3, and then of course, I am not going into the C direction. So, it will be 0 there. So, this is what is the indexing we have to do in case of hexagonal system to take care that we are going along all the 3 directions. Okay. Now, if you just do it like this, sometime it becomes very difficult. Okay. So, to simplify this whole idea, actually you can convert between the 3 indexing system to 4 indexing system very easily, and there are relations which are given here, okay, to do that. So, every time to find out that how to go in all these 3 or all in these 4 crystal axes, okay, and finding out the right indexing of the particular direction becomes little bit difficult. Okay. So, what we do is we do it in 3 indexing system and then we convert it into 4 indexing system. Okay. So, for example, we will take the this primary direction itself as an example. Okay. So, let us see. Okay. Okay. So, this is my center, this is A1, this is A2, this is A3. Okay. Let us suppose we index A1 using our 3 indexing system which we used for Miller indexing system. Okay, sorry, A3 I draw wrongly, A3 will go here. Okay. So, A1 will be from that system, it will be 1 0 0, the UVW will be 1 0 0. Okay. Now, let us use this conversion which is given here to find out that what will be in the 4 indexing system. Okay. So, u will be equal to 1 by 3 2u minus v. So, 1 by 3 2 into 1 minus 0. Okay. This is equal to 2 by 3. P will be equal to 1 by 3 2 v minus u is given there. Okay, or I can write it as minus u plus 2v whatever. So, it will be 0 minus u plus 2v. So, it will be minus 1 plus 2 into 0, that will be equal to minus 1 by 3. T will be equal to whatever you are getting u and v here, okay, negative of that. So, minus u plus v, that is equal to minus of 2 plus 3 minus 1 by 3 here. So, that comes to minus 1 by 3, okay, and w is w. W is 0 because the last one is 0 here. Okay. So, this is coming as this my and 0. Okay. And now, I have to take the integer of this because it is in fractions. Okay. So, I will just take the integer values of this. So, it will come as 2 minus 1 and 0, and which I can write as 2 bar 1 0. Okay. So, I think it is same as what we said, that the 1 0 0, the A1 axis should be 2 bar 1 0. Okay. And this you can do for any direction. Now, we can take any direction, maybe let us say we take a direction like this, starting from here, maybe going there. Okay. So, let us say this is the direction we are talking about. Okay. So, going for this direction, what we will have to do? I will have to, this is my negative A1, this is my negative A1. Okay. So, for going to this direction, I will be going in the negative A1 direction, okay, and positive C direction. Okay. Can you see that? Negative A, positive C will get me to the end point of this particular direction. So, in 3 indexing system, I will write this particular as minus 1, okay, nothing in 0 A2, so 0, okay, and in C it is 1. Okay. So, again we will do the calculation. So, u is 1 by 3, 2u minus v is 2 minus 1 minus 0, okay, that comes to minus 2 by 3, okay. V is equal to again 1 by 3, it is minus u, so minus u is now become plus 1 plus 2v, 2 into 0, okay, that comes to 1 by 3. T is minus of u plus v, that is minus 2 by 3 plus 1 by 3, okay, it will be 1 by 3, okay, and w is equal to w, so it will be 1, okay. So now again we can write it there, so it is minus 2 by 3, 1 by 3, 1 by 3 and 1, okay. So now again I will take the integer, I will multiply the whole thing by 3, so it will become minus 2, 1, 1 and 3. So this particular direction is part 2, 1, 1, 3, okay. Similarly, I can find out the, let us say in this case, because I went into only one direction, let us say we want to find out a direction like this, starting from here, let us say it is going up to here, okay. So now for this one I will be starting from going in A1 direction, then A2 and then C. So for this I will be going along this, then I will be going along this, then I will be going along this to get to the final point, okay. So this will be in 3 indexing system, it will be positive in A1 positive 1, then again A2 positive 1 and in C again it is positive 1. So let us see now find out our indexing for this u, again 1 by 3, 2 into u, 1 minus v is equal to 1 by 3, v 1 by 3, it is minus of u plus I will write only 1 plus 2 into 1 will give you again 1 by 3, then t will be equal to minus of u plus v, so 1 by 3 plus 1 by 3 equal to minus of 2 by 3, okay, and w will be 1. So let us write it there, it is 1 by 3, 1 by 3 minus 2 by 3, 1, again you multiply by 3 all over, so it will be the indexing finally will be 1, 1 bar 2, 3, okay. Now you may be wondering whether all these things we are getting the right direction or not in actual terms, okay, because we are just keep on changing from 3 to 4. Let us say suppose you actually want to find out this from this particular indexing which is given here, okay. So let us say I have to go in one unit here, so I will do it with blue right now. So one in this, then another one I have to go here, then I have to go to negative in A3, so I am going to negative in A3, so A3 positive is this direction, so 2 negative of that will be something like this, okay, and then I have to go 3 units in C direction, so my C is like something like this, okay. So maybe I am going something like this in 3 units. So if you see here, I may be ending there, okay, this is my direction. So what I did in 3 indexing system using our knowledge of Miller indexing system, using only A1, A2 and C, okay, I am able to convert that into 4 indexing system and I am getting the direction which we should have from what we have got here, okay. So this is working, there is no problem here, okay, and we will again do some assignments to get hang of the indexing method. Okay. More example will give you a better idea. Okay. So, the simplification is already done. Thank you very much. I think it will be a big lecture, and if we understand that, we will be able to do a good job of indexing planes and direction, and you will start getting the a picture or visualization of the when we say certain plane, you will be able to immediately see okay which plane we are talking about. Okay, in case of cubic crystals or hexagonal crystal, or if we say one direction, you will be able to picturize okay which direction we are talking about. So, once we have too many exercise to do all this direction indexing and plane indexing, you will be able to do that. So, thank you very much for your patience.